Hey folks, today's topic is recursive and explicit sequences. So just a quick reminder of what a sequence is. It's just a list of numbers. So a sequence is, we're going to get into these things called series, where we take the list of numbers and add them up. But today we're just kind of talking about what sequences, just a list of numbers are. We're going to get into two styles of sequences, explicit and recursive. But let's first talk about how we denote, what's the notation that we use when it comes to sequence notation. So we would call any random term, we call it the A term, and then the subscript is what term it is in the list. So this would be read A sub 5 equals 15. And each little piece means something. So if I were to circle this, this is what we call the term number. And this and this are what we call the term. So it gets a little confusing because we have term and term number. The term number means where it is in the list of all the terms. I should have done a better job with that. The term is the A sub 5 together. That whole piece is the term A sub 5. So A sub 5, ignore that little A. The A sub 5 is the whole term. 15 is also known as the term. So one is kind of in its like f of x notation, and one is the actual value. So we've got the term number represents the where you are in the list, and then the actual term, the number itself is 15. So my term number would be 5, and the fifth term would be then 15. And we denote our sequences. We call the first term would be A sub 1, the second term A sub 2, A sub 3, and so on. And then we get into kind of the random, if I want to talk about any random term in the sequence. Now I'm going to leave a gap here because I'm doing this on purpose. I'm going to pick any random term. We would call that term A sub n. So how did I go from the first term to the second term? How did I know that after A sub 1 would become A sub 2? Now, we just know that to be true, but what's the mathematical reason? What did we do to these numbers? Well, we added 1. So what's the term after A sub n? That would be A sub n plus 1. Whatever this number is, I don't know what it is, but whatever it is, we would add 1 to get the next term. What would be the term after that? A sub n plus 2. And so on, and A sub n plus 3, and so on, and so on, and so on. Well, if we go the other direction, what was the term right before A sub 3? It would be A sub 2. How did we get that? Well, we took A sub 3 and we subtracted 1. So if we have A sub n, who is the term before A sub n? Would be A sub n minus 1. And the term before A sub n minus 1 is A sub n minus 2, A sub n minus 3, until we get down to A sub 1. So this is kind of how we denote, how we designate our sequence and the terms in that sequence. So the third term is called A sub 3, and it's some number. It's not necessarily 3, but 3 represents where it is in the list. So we have two different styles of sequences. We have what are called explicit sequences and what are called recursive sequences. Explicit sequences are pretty nice. All you have to do is, they're explicit because you just plug and chug. So what I mean by that is, if I want to find the first 4 terms of, and then here's my rule, well, what would the first term be called? It would be called A sub 1. Now look at what happened here. A sub n became A sub 1. This is similar to when we have something like f of x equals, and you got some equation, and then I say, what's f of 2? How would you find f of 2? You take 2 and you plug it in for x. So what changed between A sub n and A sub 1? The n became the 1, so that means anywhere there's an n, I'm going to plug in a 1. So this would become negative 2 times 4 to the 1 minus 1, subtract 11. Now, if you need your calc, go get it, but I can do this in my head. 4 to the 1 minus 1 is 0, so 4 to the 0, that's worth 1. 1 times negative 2 is negative 2. Negative 2 subtract 11 is negative 13. Now I want to find the second term. It says find the first 4 terms. We found the first one. Now we want to find the second term. So I would take 2, a sub n becomes a sub 2. So I'm now going to put 2 in for n in my formula. So let's see if we can do this one in our head. That's 1, that's 4. 4 to the 1 is 4. 4 times negative 2 is negative 8. Negative 8 minus 11 is negative 19. If I want to find the third term, negative 2 times 4 to the 3 minus 1 minus 11. This might be getting a little bit tougher. That's 2, so that's 16. That's negative 32, so that's negative 43. And hopefully you're getting the pattern by now. A sub 4 would be negative 2 times 4 to the 4 minus 1 minus 11. And excuse me, I definitely would need my calculator to do that. And we get negative 139. So what is the third term in the sequence? We would say the third term is negative 43. Just to be clear on what I mean by term versus term number. What term number is negative 19? Negative 19's term number is 2. Do you see the difference between the two things? Now, you can either leave your answer like this. I don't care if you want to just box in right here, but technically we should write it as a sequence. Negative 13, negative 19, negative 43, negative 139, and then box it in. It looks a lot nicer this way. Let's have you try the next two. You try the next two on your own. I'm not going to show my work on the next couple ones. I'm going to do it all on my calculator. All right, let's see here. So I want the first term. So that'd be 16 minus 6 times 1. So my first term would be 10. I'm going to go second enter. I'm going to change the 1 to a 2. My next term would be 4. Second enter, change the 2 to a 3. That next term would be negative 2. Second enter, change it to a 4. We would get negative 8. So there's my first 4 terms. In my class, it's almost always the first 4 terms. In another class, maybe it's something different. I don't know. I'm going to do this on my calculator as well. So if you want to plug and chug, I'm going to use my fancy alpha F1 keys to make my answers have nice fractional answers. So this is a fraction overall. So alpha F1, remember n over d allows you to make it into a fraction. 6 times my first term would be 1 over 2 times 1 squared. I probably should use parentheses there. 1 squared plus 1. Now, if you use this fraction mode, it'll spit back your answer as a fraction. So we get, this one, first one is 2. So I guess that's not going to be a fraction. 2, comma. Now, I'm going to hit second enter because I can just go back and change these now. I want the 1s to become 2s where those n's were. And I get 4/3. Now, maybe you got 1.3 repeating. That's fine as long as you write 1.3 with the repeating sign. I'm fine with that. It'd be nice for you to frack it back, but you don't have to. Then I want the third term. I'm going to go back and change the 2's to a 3. We get 18/19. And then my fourth term, change it to a 4. And we get 8/11. What do you think? So I'm going to save this until after we talk about recursive formulas. So recursive formulas are easier to come up with a rule for, but they're harder to evaluate just because the notation is kind of weird. So in a recursive sequence, every term is based on the term before it. So the rule is based on the term before it, which means I have to tell you what the first term is. So if I'm going up here, the way I think about it is a sub n is the term that I want. Now, if the term that I want is based on the term before it, then a sub n is based on a sub n minus 1. That's called the previous term. So that's what this notation means. I want a sub n. This is the term that I'm trying to get. To use that, I need to base it on the term before it. Now, what messes people up is they think they have to subtract 1 from some number. Really, you're only subtracting 1 in your head when you think about this as a previous term. So if I want the fifth term, this is the fourth term, the term before the fifth term. If this is the 11th term that I'm trying to get that I want, then the previous term would be the 10th term, okay? So this just means what was the term, what was the answer before the one that you want. So that's why they have to give us the first term, because our first term, a sub 1, what would be a good color here? A sub 1 is equal to negative 3. They had to tell us that. Well, what happens when I want to find a sub 2? A sub 2 is my second term. So a sub 2 is equal to, the formula says 2 times, and then it's 2 times the previous term. Well, we just calculated that the previous term was negative 3, and then we still need to plus 1. So 2 times negative 3 is negative 6, plus 1 is negative 5. Okay, now I want the third term. So the third term then would be a sub 3 would be equal to, okay, what's the rule? Any term that you want is 2 times the previous term. But now, who was the term that was previous to a sub 3 was a sub 2. So I'm going to take this answer. Notice I took this previous term, I plugged it in to 2 times whatever plus 1. I got a new answer. That became my new previous term. So if I want the third term, I take the one before it. Don't forget you still need to do a plus 1 at the end. So that's negative 10 plus 1 is negative 9. And then I want to go for my fourth term. A sub 4 would be equal to 2 times my previous term. Well, the answer that we just figured out was negative 9 plus 1. That's negative 18 plus 1 is negative 17. So what are my terms? What are the actual terms of the sequence? I'm going to list all of those terms that we found by plugging in the previous term. So we would have something along the lines of negative 3, negative 5, not something along the lines of exactly. Negative 3, negative 5, negative 9, negative 17. Okay, now that we've talked about it, let's have you try pause here and try to do this next example. What do you think are the terms of that sequence? Okay, let's see how you did. So, my first term would be 5. My second term would be negative 3 times the previous term, which was 5, plus 2. So my next term would be, oops, where did I mess up? Oh, I wrote plus 5. Negative 3 times the previous term, which was 5, plus 2, which would be negative 13. My next term would be negative 3 times my new answer, which is negative 13, plus 2, so that would be positive 41. Then negative 3 times my previous term, which was 41, plus 2, which is negative 121. What do you think? All right, let's have you try another one on your own. First term, and then go from there. All right, my first term is 0. Now I'm going to use fancy calc here, alpha F1 n over d. So previous term was 0 plus 2 divided by 5. So that's 2/5. Second enter. Now my previous term, ooh, this one's kind of annoying. So I'm going to show you a trick here. Instead of plugging in 2/5, which you could, 2/5, that would be fine, and you could get your answer plus 2. You could get your answer that way. I'm going to do previous answer. So what I mean by that is I'm put in 0 first. 0 plus 2 over 5. Then I'm going to go answer plus 2 over 5, and that spits back 12/25. Now, you might have got that by fracking back. That's fine. Now, I can do that again. Second enter. That's going to take my last answer, and it's going to put it in there, and that's going to give me 62 over 125. Now, if you did those as decimals, that's fine. That's fine. I'm okay with that. Prefer fractions since it's so easy to frac back. All right, so what's the real power? Why do we care about the two terms, two different styles? You're going to have to trust me. I don't have you guys writing out the rules for the sequence on your own. But finding the big difference between finding an arithmetic, an explicit, and a recursive sequence is how quickly you can find the term that you want. If I want the sixth term, over here it's nice. I can just go find the sixth term. A sub 6 is equal to negative 4 times 2 to the 6 minus 1 plus 18. That's something I could type into my calculator, and I would get negative 110. The other style takes a little bit more work. So if I want to find the sixth term, I need to find a sub 1, and I need to find a sub 2. That would be 1, 3, negative 1. I would need to find a sub 3. A sub 3 would be negative 3, negative 7. A sub 4 would be negative 7, negative 21, negative 25. Then I would need to find a sub 5, which would be negative 75 minus 4 is negative 79. And then finally, I could go find a sub 6. 3 times negative 79, subtract 4, negative 241. So you might say, why do we ever do a recursive rule, right? Look how much longer it took than when we found the sixth term of an explicit rule. And yeah, we do like explicit rules the best, but recursive rules are usually much easier to figure out. So that's kind of the reason why we don't always just do it in one term. All right, homework's on the back. Good luck.